Welcome to Module 5 video continuation, which is part 4. So let's discuss the data deduplication, which is a KTU question. So what is data deduplication? It is a process of identifying and eliminating redundant data. So it naturally reduces the storage requirements for backup. There are two methods, that is file level and sub-file level deduplication. Then two implementations are there, that is source based deduplication and target based deduplication. We'll discuss it further down. Now the key benefits of data deduplication. So as you know, it is just removing redundant data. So the storage can be saved. Okay, so you find that it reduces the infrastructure costs, okay, because you have more space for other things. Then it enables longer retention periods, so it reduces the amount of content in the daily backup, so whatever existing can be there for longer periods of retention. Then reduces the backup window, so as we said, the window can be used for other things, okay, since the redundant data is removed. Then reduces the backup bandwidth requirement. Next, explain data deduplication methods. So this is again KTU question. So two methods. First, file level deduplication. So in file level deduplication, it detects and removes redundant copies of identical files. So it stores only one copy of the same file. Okay. Then in sub level or sub file deduplication, the sub-file deduplication breaks the file into smaller chunks and then uses specialized algorithm to detect redundant data within and across the file. So the previous case, it just checked similar file names, but here within the files any redundant data is checked and removed. Okay, so there are two forms of sub-file deduplication, that is fixed length block and variable length segment. Fixed length block deduplication divides the file into fixed length blocks and uses a hash algorithm to find duplicate data. Okay, so this might miss opportunities to discover redundant data because they are checking only fixed length. Now in variable length segment deduplication, if there is a change in segment, the boundary for only that segment is adjusted. So it checks more than the fixed ones. Okay, so it is better than the previous. Now we talk about the implementation methods. First is source based data deduplication. So it's very simple. The figure is also very simple. It eliminates the redundant data at the source before it transmits to the backup device. So you can see in the figure, you have the backup client and you have the data set. So at the source itself, deduplication is done, okay, and then only it transfers to the backup device. So just go through it. Then in target based data deduplication, the figure is here again very simple. So deduplication is done at the target only, okay, so the network is more crowded than the previous one, okay, here only 2, here more as in the source, okay. So you find that the target based data deduplication occurs at the backup device, which offloads the backup client from the deduplication process, okay, unlike the first type. Then you have two types here, that is deduplication at the backup device is done immediately, that is inline, or at a scheduled time, that is the post process method. So inline deduplication, what is it? It performs deduplications on the backup data before it is stored, that is immediately as it arrives. Okay, then in the post process deduplication method, it enables the backup data to be stored on the backup device first and then only it will be deduplicated. That is, it's a later process. First the storing is done, okay, and the deduplication is scheduled later. Okay, now is replication. Replication is another topic actually. So we had learned BC, business continuity. It has many technology solutions we had discussed. One method was backup. Okay, among the three methods we mentioned earlier in the part 1 video, we said backup was one method. So after backup, replication is also another method which ensures business continuity. is just a process to create an exact copy of the data. Okay, so these replica copies are used for restore and restart operations if in case the data loss occurs. Okay, so it is a way to ensure business continuity. Then replication can be classified into two major categories, that is local replication and remote replication. So we'll be discussing local replication first, then remote replication. Okay, so both are like giant questions. You have local replication essay, remote replication essay. Okay, then it refers to local replication refers to the replication of data within the same array or same data center, whereas remote replication means data at the remote site is replicated. So what are the uses of this local replica? So it is an alternate source of backup. It helps in fast recovery, decision support activities. Okay, that is, if you have a replica or a copy of the source, you can easily make decision activities or recovery process and all can be done very easily. That is the use of the local replica. Then testing platform, it is very useful to have local replicas. Then data migration is easy, that is migrating from a smaller capacity logical unit to a larger capacity one is easier when you have replica of data. Next, replica characteristics. So first one, recoverability. So it is very clear from the term itself. Okay, replicas help to recover fast. Then restartability, consistency. So consistency is a point which you have to go in detail. Okay, so consistency, replica must be consistent with the source so that it is usable for both recovery and restart. Okay, then replicas can be either point in time bit or continuous. Point in time means the data on the replica is identical image of the production at some specific timestamp, means it is identical one. Continuous replica means the data on the replica is in sync with the production data at all times. It is a continuous process. The other is at a specific timestamp. So how is this consistency achieved? Okay, in file system FS as well as in database replication. So how is the consistency done in file system as well as database? Now there are two methods actually in each of them. So in file systems, consistency can be achieved by either taking the file system offline, that is unmounting the file system, or keeping it online, that is by flushing the host buffers before creating replica. Okay, just memorize it. Okay, so by offline method and online method. Okay, then in case of databases, the similar solution, that is take the database offline or take it online. Online here is done by using dependent write IO principle or holding the IOs before creating the replica. Okay, so this is summarized in this table. You can see in offline method, okay, consistency, this is for consistency. In the offline method, in case of file system, you just unmount the file system, and in the online method you just flush the host buffers before creating a replica. And in the database, how to achieve consistency? In the offline method is shut down the database. Okay, then in the online method you use A and B part, that is using dependent write IO principle or holding IOs to source before creating replica. Okay, so this is just the explanation. Okay, same thing is mentioned, that is if the file system is unmounted before creating the replica, the buffers will automatically be flushed and the data will be consistent on the replica. So unmounting is a method, okay, offline method. Okay, and when it is turned online, the buffers will be automatically flushed and the data will be consistent with the replica. Okay, then this is just a figure, simple figure, just to show that some application file systems memory buffers. So memory buffers has the flushing unit, flush buffer, and the data is flushed. Okay, so you find that that is for file system. Now for database consistency, again it is said in the online method, according to like a replica is consistent on the online case by using the dependent write IO principle or holding IOs to the source before creating the replica. Same point. Next is describe host-based or array-based and the network-based local replication technologies. So this is what I was talking about. The local replication technologies as an essay question. Okay, there are actually three parts. So first is the host-based. Okay, then comes the array-based. Just turn the order. It's better to discuss array-based, then the network-based. Okay. So in host-based replication, there are mainly two types. Okay, this is for local replication. Okay, so first is LVM based mirroring, second file system snapshot. Okay, so first one, LVM. In LVM based replication, you have the logical volume manager responsible for creating logical volumes. Okay, that is very clear to you earlier. And LVM has three components, that is the physical volume, then the volume groups, and the corresponding logical volumes. So these are the physical, and this is the corresponding logical. Okay, so in LVM based replication, each logical block in a logical volume is mapped to two physical blocks on two different physical volumes as shown in the figure. So the figure is right here. So you have a volume, okay, and each block is mapped to two physical blocks on different physical volumes. Okay, so it is a case of replication. Okay, and this is called LVM mirroring. Okay, and advantages, it is not dependent on any vendor specific storage and no additional license there. The limitations, there is an additional burden of copying, so it can degrade the application performance. Then if there is a RAID already implemented, then LVM mirroring would be unnecessary. Then replica would be unavailable if there is any error. Then if the server fails, both will be unavailable. So these are the disadvantages. Now the next type under host based replication is file system snapshot. Okay, so this again, there will be a source and you are creating a replica. Okay, that is the key thing that you have to keep in mind. So file system snapshot is a pointer based replica that requires a fraction of the space used by the production file system, and it uses copy on first write principle to create the snapshots. Okay, so when you're going to do the first write, you create a copy. Okay, that is a snapshot. And snapshots, there will be a bitmap and a block map created in the metadata. So you can see the file system, this is the production file system. Okay, when some metadata like data A, B, C, etc. Okay, so on the first write, they create a snapshot. Okay, and the snapshot will have a bitmap and a block map. Okay, so bitmap is used to keep tracks of the blocks that are changed. Okay, and block map is used to indicate the exact address from which the data is to be read. Okay, and in a copy on first write mechanism, if a write IO is issued to the production FS for the first time after the creation of snapshot, the IO is held and the original data of the production corresponding to that location is moved. So if you are doing it for the first time while creation, the IO will be stopped, will be held, and the original data will be moved to the snapshot. Okay, so that is the kind of replication. The write is allowed to the production FS then. Okay, the bitmap and block map are then updated accordingly. Okay, and subsequent writes, if you do, it won't initiate the COFW activity. Okay, to read, it is similarly done consulting the bitmap. Okay, if 0, the the read is directed to the production FS. If it is 1, the block address is obtained from the block map. So using these two, the corresponding operation is done, that is read operation is done. Okay, so I'm concluding here. Storage array based local replication in the next video. Thank you.